Hi, ladies and gentlemen. We have been looking at, we looked at the Pythagorean theorem. So today we're going to look at SOH CAH TOA, which are trigonometric ratios. So trig ratios, which sounds scary, but it's really not. So trig ratios. The first thing I need to review with you is being able to identify the different sides of the triangle. So if we have a triangle, let's do draw two triangles here. So the first triangle, whoop, there we go. We'll do another triangle. It's like similar. So two triangles, 90-degree angles. Let's say this is A, this is B, and this is C. A, B, C. All right, so we have our two triangles. Now, depending on the angle that we're looking at, so let's identify, let's put an X here, this triangle and this one. Okay, so when we are looking at our triangle, remember that from the Pythagorean theorem, what we discussed there was that the side that is across from the 90-degree angle, so in this case B is our angle where the 90 degrees are. So the side that is directly across from that 90-degree angle is always the hypotenuse. So this side is my hypotenuse, and it's going to be the same on the other triangle. Okay, those are both the hypotenuse. I'm going to write this over here, hypotenuse. So there's our hypotenuse. Now, depending on the angle that we're looking at, that's going to change what we call the different legs of the triangle. So if we're looking at this angle right here, this X, the side that is directly across from this angle right here, we call that our opposite. It is opposite the angle we're looking at, so this side is opposite. And so we'll write opposite. And then the side that touches the angle that we're using is our adjacent side. Adjacent. Okay, so for this triangle, because we're using this angle, this side over here is our opposite, and this side, because it's touching the angle, is our adjacent. Adjacent means next to. Now on this triangle, again, the hypotenuse is always going to be the same because it's the side that is across from the 90-degree angle. But we're looking at a different angle here. We're looking at angle C instead. So we have to label this one differently. So the angle that is right across, the side that is right across from this angle, right? This is our opposite. Okay. Now this side is touching the angle, so it's next to the angle, so this side is our adjacent. So it's important to be able to label the triangle correctly depending on the angle that it's being identified, because the legs will change depending on which angle we're looking at. So trigonometric ratios are these. SOH CAH TOA. So I need you to memorize SOH CAH TOA, and this is where we're going to use those kind of fancy buttons on your calculator. Okay, so you have that button that says sin, that stands for sine. You have the button that says cos, that stands for cosine, and you have a button that says tan, that stands for tangent. So we use SOH CAH TOA to remember which sides of the triangle we are using for which ratio. So for example, sine is opposite over hypotenuse. cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So that's what that stands for now. You're thinking, what are you talking about, Mrs. LaJoy? So let's do some examples to show how we figure out and how we use our calculator with sine, cosine, and tangent. All right, so going over some examples. So this first example here, we have a triangle that is labeled with angles ABC, and we have sides with measurements of 5, 13, and 12. So here's our 90-degree angle. So first of all, let's look at how we can set up our trigonometric ratios depending on which angle we're looking at. So let's say we're looking at angle A. Okay, so this angle right here. So for angle A, if we are finding sine, and let's write SOH CAH TOA again. So SOH CAH TOA. So for sine, we have the opposite over the hypotenuse. So let's label this triangle, but that way we can solve this question. So the hypotenuse is going to be the side that's across from the 90-degree angle. So that means this side right here is our hypotenuse. Because we are using this angle, the side that is opposite this angle is this one over here. And the side that is touching the angle, the adjacent side, is this one here. All right, so if we are finding the sine of angle A, I can write sine angle A equals, remember that sine is opposite over hypotenuse. So opposite over hypotenuse. So that means our sine of A equals opposite, which is 5, over hypotenuse, which is 13. If we do if we do cosine of A, cosine of angle A, remember that cosine is adjacent over hypotenuse. So adjacent over hypotenuse. Now the adjacent side was 12 over the hypotenuse, which was 13. There we go. And if we do if we do tangent, so tan of angle A, tan is opposite over adjacent. So opposite was 5. Let's write opposite over adjacent. So opposite was 5 and adjacent was 12. And that's all we have to do for this question. I want to look at let's look at some examples from the homework that I'm going to give you. So in the homework, on the first page, we have a triangle where we have to do what we've just done. So let's draw this triangle out. We'll do the first one together. So here's our 90-degree angle. This is B. This is C. And this is A. We have measurements of 3 centimeters 5 centimeters and 4 centimeters. And it shows us this angle here. It's 37 degrees. So we have a chart down here that's asking us for triangle ABC, which is this one. It wants us to do sine of A, cos of A, and tan of A. So let's see here. So sine of A. Let's write our kind of cheat sheet up here, just so we remember. So CAH TOA. So sine of A. So we have the measurement of the angle, so we're going to use that. But if we're doing opposite over adjacent, that first column there, opposite over hypotenuse. So that first column there asks us to list our opposite over our hypotenuse. So opposite over hypotenuse. Now the opposite is, we can even label this. Let's label this triangle. This triangle, if we have our right angle here, that means this side is our hypotenuse. If we are using this angle here, this 37 degrees, the side that is across from the angle is our opposite. And this side is touching the angle, so this side is our adjacent. Okay, so back to the question. So opposite over hypotenuse, the opposite is 3, and the hypotenuse is 5. So the question asks you to round answers to 1 decimal place. So if we do 3 divided by 5, we get 0.6. You can also type into your calculator using that sine button. If you do sine 37 and then press equals, you will also find that sine 37 equals 0.6018. Okay, so that's what you're going to fill into the column that says sine A. So sine 37 equals 0.6018. Now you're also asked to find the cos of A and the tan of A. So for the cos of A, remember that cos is going to be adjacent over hypotenuse, so ADJ over the hypotenuse. So the adjacent side is 4, and the hypotenuse is 5. So 4 divided by 5 is going to be 0.8. And then in your column that says cos A, again, you're going to use the button on your calculator that says cos. So if you type cos 37 equals, you should get, actually I should write these down here. So for sine 37, we got 0.6018. For cos 37, we got 0.7986. The last one that we're going to look at is tan. So for tan of A, or that tan is going to be opposite over adjacent, so the opposite side over the adjacent side. So the opposite side was 3 over the adjacent side, which was 4. When we do 3 divided by 4, we get 0.75. And if you use the button on your calculator and you put tan 37, you should get 0.7535. So you can see here that we can find the same answer If we didn't have the measurement of that angle, we just had that angle as the one we were using, and it was, you know, x, we can find what that answer is, what the sine, cos, or tan is, just by using the sides of the triangle. Or we can use the button on the calculator if we know what the angle is. So that's the first question. You have another triangle, you have to do x, y, z, but we've done the first one together, so give the second one a try. The other questions in the homework, let's skip over to the second page. So on the second page, we'll do the first one together. So you have a triangle and you're asked to label it using the side names opposite, adjacent, and hypotenuse. So let's look at the first one. The first one, we've got this triangle here. Here is our 90-degree angle, and this triangle is labeled with M, N, O. Now the identified angle, that's important, right? Which angle, because it depends on how we label it, what our angle is. So the angle they have identified is this one up here for M. So when we label this, remember that the hypotenuse is the side that is across from the 90-degree angle. So therefore this is our hypotenuse. Now if we're using this angle here, that changes how we identify the legs. So from this angle, the side that is across from it is this one here. This is our opposite. And the side that is touching the angle but is not the hypotenuse is the adjacent, because it's beside the angle. So that's all you have to do for that question, is just label the triangles with the correct sides. For the next question, you're going to use your scientific calculator and you're going to type, just like we did in the chart in that first question on the first page, you're going to type in each value and find the answer to 4 decimal places. So for example, you have been given sine 65, so sine 65 degrees equals, so if we type sine 65 into the calculator, you want to get used to what sequence your calculator uses. So some of them you have to put 65 sine, sometimes you can put sine 65. It depends on the calculator that you have. Sometimes you might have to use brackets around your number, I'm not sure. It's hard to say. So what you want to do is play around with it and know that this should be your answer. So for the first one here, for sine 65, your answer should be 0.9063 to 4 decimal places, okay? So try the different sequences with your calculator and figure out which order you have to type things in, knowing that this is the answer you're looking for this, okay? And then try out the other questions. We're going to do one of question 3 together. So I'm going to draw out this triangle. We're asked to solve for side x. So here is a triangle. Okay, and this is side x. This is our 90-degree angle. And this side is 14 meters. And it gives us this angle and says it's 29 degrees. So we have to solve for side x. So the first thing we want to do is figure out, first of all, let's label this triangle, right? So if we label this triangle, remember that the side that is across from the 90-degree angle is our hypotenuse. So that means this is the hypotenuse. It's given us this angle here. That means that the side that is across from the angle is our opposite, and the side that is touching the angle is this one here. So this is our adjacent side. Okay, so our triangle is properly labeled. So now we have to figure out which trig ratio to use. So we have SOH, CAH, and TOA. Now we have to figure out the information that we have and which one is the best to use. So for sine, we need our adjacent and our hypotenuse. We have our adjacent, we don't have our hypotenuse, but this doesn't help us because we have to find the opposite side. So we can't use this one because we would have to have the hypotenuse. So this one's out. For cosine, we need the adjacent and the hypotenuse. We have the adjacent. We don't have the hypotenuse. The problem is we're looking for the opposite. That's not included. Get rid of that. For tan, we need the opposite and the adjacent. This one works because our opposite is the one we're looking for and we have the adjacent. So we're going to use tan. So how do we do this? So I'm going to write out, first of all, tan is opposite over adjacent. So for this one, we know that it's 29 degrees. So here's how we're going to write this. We're going to put tan 29 equals our opposite side, which is x, over our adjacent side, which is 14. So really what we have to do here is isolate for x so we can figure out what our x is. So how do we do that? We've got a fraction here, x over 14. So how do I get the x by itself? I have to do the opposite operation. This is x divided by 14. So if I multiply by 14, these two 14s will cancel out. And whatever I do to one side of an equation, I have to do to the other. So that means I have to multiply the other side by 14. So I have now tan 29 times 14 equals x, right? Those two 14s on the other side canceled out, so I was just left with x. So now I can figure this out. If you type tan 29 into your calculator, you should get 0.5543, and then times 14 equals x. So 0.5543 times 14 should give you 7.8 equals x. So now we can write our therefore statement. And remember that our triangle showed our measurements in meters. So we can write therefore x is 7.8 meters. We'll look at one of the word problems together. So let's see. If we look at question 6, so question 6 says the cathedral bluffs in Toronto, Ontario are eroded sandstone cliffs that rise 90 meters above Lake Ontario. Natalie is 1.4 meters tall. From her position at the top of the cliff, the angle between the surface of the lake and her line of sight to the boat is 39 degrees. Find the distance between the boat and the base of the cliffs, the nearest tenth of a meter. Okay, so this sounds really complicated, but it's not. So first of all, you've got a diagram there that shows you what this looks like. So we have this triangle here. So we have the cliff that is 90 meters, and then Natalie is up here at the top, of the cliff, and this part here is 1.4 meters, right? We have a 90-degree angle here. Down here, we've got this boat in the water. So the angle is 39 degrees down here. Okay, so what we have to do first of all is figure out, well, this side, we'd have to add these two together, right? Because we have the 90-meter cliff and the 1.4 meter person. So we add those together, and this side equals 91.4 meters. So there's our triangle. So first of all, let's label the different sides of this triangle. So again, this is our 90-degree angle here. What side? Remember, the hypotenuse is right across from the 90-degree angle, so this is the hypotenuse. Since we have this angle down here at the bottom, remember that the side that is right across from that angle is our opposite, so that means this 91.4 is the opposite. And this one down here is the adjacent. So what is it this question is asking us to look for? Find the distance between the boat and the base of the cliff to the nearest meter. So what are we looking for? We're looking for this right here, this side. Because the boat is over here. Let's draw a little boat. That's a great boat, isn't it? So we want to find the distance from the boat to the base of the cliff. So we are looking for this side here. Our x is on our adjacent side. So which form can we use? Let's figure it out. SOH CAH TOA. So can we use sine? Well, we would need our opposite and our hypotenuse. We have the opposite. We don't have the hypotenuse. But that doesn't really matter because we need to find something that has the adjacent in it. So sine isn't going to work, right? Cosine uses the adjacent, which we need, and the hypotenuse. We can't use that because we don't have the hypotenuse, right? So cosine doesn't work. But tan, we are looking for the adjacent, and we have the opposite. So tan is going to be the way to go here. Okay, so we are going to write out what we have. We've got tan 39 equals, remember this is going to be our opposite over our adjacent. So our opposite was 91.4 and our adjacent is x. That's what we're looking for. So in order to do this one here, let's rewrite it. Tan 39 equals 91.4 over x. So in order to get our x by itself, we have to move things around a little bit because the x here is on the bottom. So if I multiply both sides by x, I'm going to get x times tan 39 equals 91.4, right? Those x's will cancel each other out. So we've just got 91.4 left on this side. So how do I get the x by itself? Well, I can, once I multiply this, I'm going to have x times tan 39. So if I divide both sides by tan 39, that will get the x by itself. Those two tan 39s will cancel out. So let's move this up here. So now I have x equals 91.4 over tan 39. Now if you use your calculator and you divide 91.4 by tan 39, When I divided those, I got 112.9. So that tells us that therefore the boat is, and remember this is in meters, is 112.9 meters away from the cliff.